This presentation was put together by me, Hirsch McNeil, the soil scientist on the Malheur, by Jordan Offit, the hydrotech who did the GIS. We covered 4 topics: rock types, slope, volcanic ash, and grassland soils. Almost all the area is the Clarno Formation. It's this crosshatched area. Here the word breccia means breccia, tuff, and conglomerate. And the word basalt means basalt and andesite. The breccia formed from ancient mud flows and landslides on the side of volcanoes. If you've been to the Clarno unit of the John Day fossil beds, you've seen breccia, which was formed from mudflow deposits. Breccia tends to weather to soils that contain high amounts of clay. Thus, many soils in the area are clayey. When wet, clay doesn't support much weight, so slumps and landslides are common in Clarno terrain. Most slumps are too small to show up on this map, but some do. This area is the Columbia River basalts, the pink. Basalts are often the hardest rocks around here, so they tend to erode more slowly over geologic time. Also, basalts tend to weather to loams with less clay than soils formed from breccia. This map shows some slumps and landslides. Yellow shows slumps from the Soil Resource Inventory from 1974, whereas orange shows possible slumps derived from our examination of LIDAR. We looked for hummocky terrain below a steep scarp. It's unusual in the Malheur to have this much landslide in a planting area. This is the result of having so much clayey soil from the Clarno. Landslide deposits can be a source of sediment, but volcanic ash and abundant vegetation help control soil erosion from the landslides. Also, the unconsolidated, porous nature of landslides mean they can act as a shallow aquifer, holding water and slowly releasing it downhill to streams, helping maintain flow farther into the summer. Many of these landslides probably started during the ice ages when there was more abundant water than at present and less vegetation. The landslides still continue to move slowly downhill with shallow creep and slumps, often only several yards across. If roads are built on landslides, care is needed to avoid causing more movement. This slide, which is based on LIDAR, shows how steep the slopes are. It's a very fine-grained map. The pixels are 1 meter square, but you can still see some general trends. The light blue is less than 15% slope. The dark blue is 15 to 35% slope. The pink is 35 to 45% slope, and the dark red is greater than 45% slope. Much of the area is hilly, with slopes between 15 and 35%, but parts are relatively level. In the north parts, up around here, the flats are mostly between streams, with small, steep canyons between the flats. They're probably located in this part of Camp Lick because the Columbia River basalts generally are relatively flat. In the southern part, the flats are near Coxey Creek meadows and in the upper part of Camp Creek. Probably part of the reason for their location is the way the land folded through geologic time. Also, a lot of the area is steeper than 35% slope, especially along Camp Creek and Trail Creek and West Fork Lick Creek and Lick Creek itself. The steeper areas may present challenges to logging system layout, especially because steep areas and flatter areas are closely intermingled. I thank Bob Hassmiller for providing this slide. This slide and the next two are based on the TEUI, which stands for Terrestrial Ecological Unit Inventory, which is what we call our soil survey. On the Malheur, the TEUI has been completed on the northern and eastern 40% of the forest. Green corresponds to soils with high clay formed from breccia, and the pink shows basalt and andesite, which can be in either the Clarno Formation or Columbia River basalts. We can see one reason for the steep slopes and for the location of some streams. The harder basalts tend to stick up higher than the breccia, with the basalts occupying the ridges, for instance there and there and there, down here, and the breccia in the valleys. Because breccias are relatively easily weathered and eroded over geological time. This map shows the coverage of the volcanic ash cap, which was deposited when the eruptions that formed Crater Lake blew ash into the atmosphere, and the winds blew the ash over much of the Blue Mountains. Here, the yellow is less than 20% coverage of ash. The dark brown is more than 80% coverage, and the intermediate brown is intermediate coverage. The ash cap is important because it's like a sponge with lots of pores that can absorb and hold water. So ash supplies water to plants, causing higher productivity and more ground cover. Because of the pores, ash also has a high infiltration rate, helping prevent surface runoff. High ground cover and low surface runoff reduce soil erosion rates on volcanic ash. Presumably, the ash was laid down in a fairly uniform layer over the area. However, in the several thousand years since the ash was deposited, it has been redistributed by wind and water. There is more ash cap at higher elevations through here, and there's a large area at lower elevation that doesn't have much ash. Also, ash tends to remain on the north-facing slopes. Here we have a north-facing slope along Camp Creek with ash, and a south-facing slope without ash. Along West Fork Lick Creek, the south-facing slope without ash, a north-facing slope with ash, south-facing slope without ash, north-facing slope with ash, alternating. But keep in mind that most soils in the Blue Mountains, including those that lack ash caps, do have ash mixed into them, improving soil properties. This map shows where the grassland soils are. More technically, grassland soils are called mollisols, or mollic soils. The light purple is less than 20% mollisols, and most of that area is 0% mollisols, and this purple is greater than 80% mollisols, and they're mostly 100% mollisols. You can see where the actual grassland and shrublands are scattered through the area. They support grassland soils. You can see the similarity to the previous slide, which showed the ash caps with areas that lack ash cap tending to have more grassland soil. So what is a grassland soil? Grassland soil has a thick, dark topsoil, resulting from the fact that many grasses and forbs put more of their organic matter below ground than trees do. But you can also see a lot of forest areas that have grassland soils. How did this happen? It's probably because these forest areas support the open park-like stands that we hear so much about, with with abundant grasses and forbs between widely spaced trees. It's been that way for at least hundreds of years in order for the top soil to form. In summary, Camp Lick supports a variety of soils that should be considered in management.